So in this example, you can see this is the thing I want to solve for. I'm going to solve the second equation for y. So it's starting out 3x plus y equals 2. When I add 3x to both sides, I get y equals 3x plus 2. So that's the value I'm going to plug into the first equation. So the first equation says 6x minus 2y equals negative 4. This is the value I'm plugging in for y, so I get 6x minus 2 times y equals negative 4. Except instead of writing y, I'll write 3x plus 2. All right, so I need to distribute to simplify this because I need to solve. I'll distribute it. Now I do have to remember to distribute the negative with the 2 here. So I'm distributing a negative 2 through the parentheses. So we get 6x minus 6x minus 4 equals negative 4. And what happens when we take 6x minus 6x? Careful about this. If your answer is x, well, think about that again. Remember, you need to combine the coefficients. 6 minus 6 is 0. So this would be 0x minus 4 equals negative 4. But 0x, that's kind of silly to write 0x. This is just 0. So really what I have is negative 4 equals negative 4. All right, something happened here. Before, when I did the solving process, I got x equals something. And what I said is that x coordinate is the x coordinate of our solution. You know, this is the situation where we got our 2 lines. I found the x coordinate of the solution, then I plug it back in to find the y coordinate of our solution. But here, what I found out is that if both of these equations are true, this doesn't say anything about the x. Instead, we just get an equation that's, well, this is true. Let's think about what's going on here. Well, we've actually seen equations like this before. This equation right here, this is where we started. That's the one we were solving. If you remember all the way back to when we were talking about the different categories of equations, we saw that if we ended up solving an equation and the variables dropped out, this is what's actually called an identity. And in this case, there are infinitely many solutions. This equation only talks about x's. And what I mean by saying that this is an identity and there's infinitely many solutions, it means that any value I take and I plug in for x into this equation, the left-hand side is always going to be equal to the right-hand side. Let's actually try a couple just to to verify this happens. Let's try what happens if x equals 10. So I'll do 6 times 10 minus 2 parentheses 3 times 10 plus 2. Now, if this doesn't depend on the value of x, I should expect to get a negative 4 out of this, because that's what the right-hand side of the equation is. And you can see there's a negative 4. So that's what happens if x is equal to 10, but let's try, I don't know, x equals 0.46, I don't know, some random number. 6 times 0.46 minus 2 parentheses 3 times 0.46 plus 2. Close my parentheses. And again, I get a negative 4. So no matter what the value of x, this equation is true. This is what it means for it to be an identity. And so there are infinitely many solutions to this equation. Now, we're actually talking about solving a system of equations. And you might guess which scenario we're in if we have infinitely many solutions to this equation. Well, we're in the situation where we have infinitely many solutions to the system of equations. We're in overlapping line territory. So when I solved this equation, I ended up with an identity, which tells me that we have overlapping lines. The identity, remember, this is where we end up with the variables dropping out and we end up with a true statement. So no matter what value of x, this becomes a true statement. This is how I know that there's infinitely many solutions and thus overlapping lines.